Hello, I'm Jordan Dwyer,
And I'm Mason Lepak.
and today we'll be examining the physics behind the impact of a bullet on a human body and analyzing the blown-away myth that Hollywood movies depict.
Action movies are typically very exciting, filled with scenes of explosions and large-scale gun shootouts that involve people being shot. Oftentimes, though, in the movies, the power of guns are very exaggerated, and people are sent flying through the air when struck by a bullet. Although this makes for a very exciting film, have you ever stopped to question where the science involved in these scenes crosses into science fiction? If you are curious about where this line becomes blurred and have a basic understanding of physics, then stay tuned as we break down the real-life physics of a couple of actual movie scenes. So first we will be examining an example from the 1998 film The Mask of Zorro.
Steal people's lives. Oh, damn ya. And down the horse that broke you!
So as you just saw, a full-grown adult man went from flying through the air with forward momentum to immediately being stopped in his tracks as if he were jerked back by a chain. The man was stopped by a single bullet fired from a .36 caliber Colt Patterson handgun. The bullet for this gun weighs about 5.2 grams and typically would leave the gun with an average initial muzzle velocity of about 353 meters per second. Judging off the man's size, it would be safe to assume he is around 160 pounds or 73 kilograms. By estimating a conservative value for the incoming man's velocity of 20 feet per second, or about 6 meters per second, and using this basic momentum equation, we found that the bullet would have had to been traveling at a speed of about 85,800 meters per second to deliver enough force to stop the man in midair. That is over 250 times as fast as the real-life speed of that bullet. Now the problem with that is that even if our hero had some type of super gun that was capable of firing bullets at that speed, Newton's third law states, every reaction has an equal and opposite reaction. For this scenario, that would mean the force of the bullet applies to the flying man and impacts him and stops him. That same amount of force would be applied to the shooter from the recoil in the gun. And if that force was large enough to stop a grown man out of the air, it would have easily knocked the man backwards who was standing still, yet he was completely unmoved. In real life, the bullet would also experience air drag and the effects of gravity that would further reduce its energy before impacting the man in the air. This would mean the man pulling the trigger of the gun would actually experience a larger force and therefore should be sent back much harder than the man in the air.
Our next example will be analyzing Last Man Standing, featuring Bruce Willis.
I guess maybe you'll have to kill me. It'll hurt if I do.
As you can see,
This
example is very similar to the first example in the sense that it's over-dramatized. However, in this scene, the victim is being shot by two .45 caliber M1911s, and he receives about 12 shots in a 4-second window. The type of bullet that's shot from an M1911 handgun is a .45 caliber bullet, which weighs 15 grams. The bullet leaves the barrel with a velocity of about 830 feet per second or 253 meters per second. That would make the momentum of this .40 caliber bullet equivalent to about 3.8 kilogram meters per second. To put that number in retrospect, the momentum of a heavyweight boxer's punch is about 60 kilogram meters per second. So that's saying that a professional boxer's punch delivers over 15 times the amount of momentum as this bullet. However, a professional boxer's punch would maybe displace a full-grown man a meter, 2 meters max. And in the strand of shots, they're all consecutive. So all 12 of those rounds have the same momentum each. So it would not change really his displacement if 12 rounds got shot or 30 rounds got shot. And theoretically, even if all 12 of those rounds hit the man at one time, he would still be experiencing a force less than of a punch. And as you can see in the video, the man is propelled backwards into a backwards somersault. He's on this route up until 4 seconds after the last shot was fired. Now we'll be examining some expert responses. Mythbusters did this experiment, and it proves our science.
Maybe what they need is something with a little more power, like, say, a Thompson submachine gun. The .45 caliber bullet leaves the carcass unmoved.
I think we just need to keep on moving up higher through the calibers.
As you can see, Mythbusters fired the same round that was fired in Last Man Standing, and the pig carcass didn't even move an inch. Now we'll examine the displacement effect that a larger round shot out of a .44 caliber Magnum will have on this pig carcass.
This is a 44 Magnum. We're going to be shooting a 240 grain bullet out of it. This is the same caliber that Dirty Harry uses in the movie.
At impact, the bullet is traveling at 1,300 feet per second. But the high-speed camera shows the pig hardly flinched.
That went right through again.
Yep.
No movement at all.
Once again, that larger round barely affected the displacement of that pig carcass.
So after seeing an example of how a bullet would actually affect a body, hopefully now you realize you can't always trust what Hollywood shows you. This example shows how anyone who has taken Physics 1 could pretty easily determine that the science involved in these movie shooting scenes is really quite exaggerated. Although this does make the movies very exciting, it's important for people to stop and consider that these are for entertainment purposes only, and it is not actually real. When people see guns portrayed as these hugely powerful devices that are capable of sending a grown man flying through the air with a single bullet, it kind of makes guns more dangerous and scary seeming than they really are. This could potentially lead to an unwarranted fear of guns from people who do not truly understand them. Not to say that guns are not a scary thing that people should be very cautious of, it's just very, very important to base these thoughts on fact rather than Hollywood fiction. Thanks for tuning in today as we broke down how Hollywood inaccurately portrays the power of guns. Remember to question the science behind everything.